Action.
Hi guys, today we're going to talk about tectonic plates. And we already know, we already studied about on page 10 of our ESRT that in the asthenosphere there are these convection currents. And the convection currents sit underneath the plates. So whatever the convection currents do, they're kind of like the boss. They're like the woman of the house. Whatever they do, everything else goes with it. So if the convection currents are moving outward, the plates are going to move outward. And if the convection currents, whoops, we just dropped a plate. If the convection currents are going to move inward, then the plates are going to move inward. So that's what's happening here. We have three kinds of plate motion. The first one is called convergent, which means the plates collide. Divergent, the plates divide. And transform, the plates slide. See how I made a little rhyme for you? Okay, look back at my hands. When we have colliding plates, if the plates are equally matched, if they're both land versus land, they'll come together, and because they have the same density of 2.7, they'll just pop up and make mountains. That's one of the ways we're going to study with convergent. The other one that we see more often is the plates are not equally matched. We have a denser oceanic plate with a density of 3.0, and we have a land plate with a density of 2.7. So when they come together, the denser oceanic plate is going to slide underneath. And you can see where the tips of my fingers are here, it makes a little trench, and that happens right down by Peru, Chile. It makes a trench, which is kind of like a deep hole in the ocean. And as the plate slides down, and you watch my fingertips, well, we know as it goes deeper, it's going to melt. And once it gets to a liquid form, it's going to shoot up into the crust, and just like my knuckles are here, it's going to create a row of volcanic mountains. That's what called a subduction zone. And here you can see it in the picture. Here's the oceanic crust sinking down. It makes a trench in the ocean, and then a little bit deeper where it melts, it makes a row of volcanic mountains. In divergent, this is what our buddy Wagner was talking about when he couldn't explain why the plates were moving apart. Well, this happens in the middle of the ocean, and as the plates move apart, it leaves a little space here where magma from the mantle comes up, and it hits the bottom of the ocean, and it cools so quickly because it's so cold that it sizzles and fizzles, and it makes new ocean floor. And then over time, it's going to keep expanding out and out and out. Remember, the continents are on top of my hands, so as we make new ocean floor, we're actually moving further and further as the plates divide. In a transform boundary, these are not as common. They create faults, and this is the one that we see in San Andreas Fault in California. This is when the plates, instead of coming together or coming apart, they slide past each other. Now, we use the word slide, but remember, these are giant plates of land and ocean. So when they slide past each other, they're not going to just gently bump into each other. It's going to be and that's where we get a lot of earthquakes at transform boundary. So now let's look at our ESRT real quick. I just want you to understand the key because that's where your assignment's going to be today. Here's our San Andreas Fault, right? This is our transform boundary. The North American plate is going down, the Pacific plate is going up, and this is the symbol that you'll see to know that that's where a fault is on a transform boundary. This one that looks like it has the little equal signs or the little scar, that's actually in the middle of the ocean. And anytime you're in the middle of the ocean, you're creating a ridge, you're making new ocean seafloor. And remember, we're gonna look at some pictures here that are gonna show exactly what a ridge looks like, and it looks like a scar. So this code that they use here is perfect. And the last one is the convergent plate boundary. That's the easiest one to see because it has these little boxes. Whenever you see those little boxes, that means one plate is sliding underneath the other. And when that happens, we create two things. We create a trench and we create a row of volcanic mountains. Lots of earthquakes here too. So little boxes, convergent subduction zone. Little scar, middle of the ocean, ridge. And the slidey one, there's only a couple of those. That's where we're creating the faults. We're getting a lot of earthquakes. All right, check out our classroom assignment for today.